date today?
October
The first.
October 1st, baby.
First of October.
Okay, 3.3, the angle addition postulate.
What is it?
It's kind of hot.
If you guys have the book, if you have it opened up to 3.3 like I asked you to, do you really need for me to tell you what the title of the section is?
I like how everything you have there.
Don't do that. Have it opened up to the section. Should be on page 104. The angle addition postulate. Okay. The angle addition postulate basically says this. Call this angle 1 and angle 2. What do you think, would you, if you were, knew nothing about it, and just went by the angle addition postulate, the words in the postulate, what would you think that would mean?
Add them up.
Measure the angles up, maybe something like that? What it basically says, you guys remember the segment addition postulate? That the two smaller parts equal what?
The whole
The whole thing? Guess what? You know what the segment addition postulate means? The two smaller parts added together equal what? The whole thing. It's the same concept. So the measure of angle 1, which is this small one right here, right? Plus what? The measure of angle 2 would equal the measure of angle, well, how am I going to name this big angle?
B.
No.
No.
But let's, well, we could, but no, we
ABC.
can't because I wouldn't know what angle you were talking about.
ABC.
Angle A, B, C. That's the angle addition postulate. Okay? Basically says that when you add them together, the two smaller parts equal the whole. Uh-oh, what do you think changes here?
There's another one.
Nothing. Just how many numbers there?
There's
With the concept of angle addition postulate, what do you think I could write here? The measure of angle 1 plus what?
angle 2.
The measure of angle 2 plus what?
Plus measure of angle 3.
What would that equal?
The whole thing.
Measure of the whole thing, which is the measure of angle.
ABC.
Doesn't change when there's more than one angle, does it?
No.
All the smaller parts that make the big part, well, you add them up and they equal what? The big part, right? You guys wouldn't have any problem with that if I was talking about distance, would you? But somehow, because we're measuring along a different deal here, people tend to sometimes have problems with this. It's just you're measuring along a circle when you measure an angle. Make sense? Everyone pay attention. I got too many daydreaming eyes out there. Okay? I want your eyes up here. I want you listening to the words I'm saying. Or you're really going to struggle with this. Other thing we need to talk about is a thing called an angle bisector. Did you guys not have this down yet?
I got one more thing to write.
Okay.
Alright, thank you, Coach.
Okay. I have a question. What do you think happens, and write down your answer, if, right, BD is an angle bisector. What do you think happens?
It cuts it in half, so then there's only.
Right now. What'd you guys, all right, now, Aubrey, what'd you have as an answer? What do you think?
I said if it cuts it in half and it counts as two separate angles.
That's true. It does cut it in half. What do you think cutting it, it cuts what in half here?
The angle. The angle, the big angle.
The big angle in half. What do you guys think? You guys like that idea?
Yeah.
Okay, cuts, so you would say it cuts angle A, B, what? C in half? So what would that lead me to say about angles 1 and 2?
That they add up to equal.
Therefore, comma, what do you think about angle 1 and angle 2 here?
They add
So-
up and equal to
Well,
ABC.
yeah, well, we know that, but,
It's separate now?
yeah, they are separate.
They're equal.
What do we use to say about two angles if they're equal? Their measures are equal, what do we call it?
Congruent?
Right, then angle 1 then must be what? Congruent to angle what?
Two.
And we use that little mark there to mark that they're what? Congruent. Right? Make sense? Those are our main two concepts from this section. After you're done writing that down, we're going to do an example on the board. Okay. Now, nobody write this down yet. Everybody pencils down. Is everybody's pencils down? Okay, when everybody's eyes up here. Now, these are the type of problems you're going to have to deal with this. Okay? Make sure to tell him to bring that up here after we're done with notes, okay? Now, first of all, let me ask you something. Does it look like angles 1 and angle 2 are about the same size?
Yes.
Yeah. Do I say it anywhere?
No.
So can you assume because they look like they're congruent, they are congruent?
No.
No, you cannot. Okay? The only thing you can assume is that if it's a straight line, that's a what? 180-degree angle. Or when we talk about vertical angles, that when two lines intersect, the opposite angles are always congruent. Those are two of the things you can always assume. You cannot assume that because they look like they're congruent, they are. Okay? What I suggest you do, and the reason I'm always making you draw the figures, is write and label the things that you know. Okay, first of all, you know that measure of angle 1 is 2x minus what? 4.
Or
So that basically means that angle from there to there is 2x minus 4, right? What is the measure of angle 2?
3x.
So from there to there is 3x. What else do you know?
That the whole
The
thing
whole
is
thing is
66.
The measure of angle ABC is what?
66 degrees.
When things look like algebra, I probably need to create a what?
Algebraic expression.
Nope, not an expression.
Equation.
Algebra
An equation. So I have to find some things that are equal. So, what do you think I'm going to do here?
2x minus 4 plus 2x
No.
minus 4 plus 3x equals 66.
Remember, I said just because they look like they're equal doesn't mean they are. Right? What do I know for sure?
That they all.
That the two smaller parts added together equal the what? Big part. Isn't that what the segment addition postulate is, right, Nathan?
Mm,
I mean, and I'll let you know a little secret. What are the two theorems we learned today? The segment addition postulate and angle bisectors, right?
mhm,
Is there a good chance the problems in this section are going to deal with that?
mhm,
That the two smaller parts added together equal the whole?
Yeah.
mm,
So wouldn't this plus this equal the whole thing?
yes.
What is this?
2x plus minus 4
Plus, what is this?
3x.
equals 66.
All of that equals the whole thing, which is,
66.
see how you made a valid equation right there?
Yes, sir.
Does everyone in here see that this angle plus this angle equals that angle?
Yes.
Does everybody understand that? That makes sense, right? You, right there, by saying that statement, you created that equation. It's just you got to get over the fact that that's ugly. Okay, well, wait a second, that should be a number. That should be this plus this equals that. It represents a number. Okay? It's just this plus what? That equals the whole thing. I just put in what this was. This was what?
1.
2x minus 4, right?
Yeah.
That was what?
3x.
The whole thing was what?
66.
Do you see how that's the same thing? Does that make sense to everybody? It's not so hard when you look at it that way. Well, how would I finish this problem?
3x plus 2x.
That would be 5x minus 4 is equal to 66. What would be my next step?
Plus 4.
I would add 4 to both sides. I'm left with 5x is equal to what? 70.
Divided by 5.
Divide both sides by what?
5.
5.
X is equal to what?
10. 12.
No, that's not right.
14.
14, right? You know what would be terrible? If you did this problem on a test and you wrote the answer was 14, but what did the question actually ask you to find?
The
Measure of angle 1, measure of angle 2, and x. I'm supposed to find all those things. Which of those have I found?
X.
X.
How does that help me find the measure of angle 1?
Because you replace the
You
x
replace
with the
the X.
number
Yeah.
Measure of angle 1 is 2 times whatever x is, which is what?
14.
14.
Minus 4. So that's 28 minus 4, so it's what?
24.
24.
This one is 3 times whatever x is, which is what?
14.
What is 3 times 14?
There's
52.
42. Now, did it work? Is 24 plus 42 66?
yes.
Yes.
Is there any way it looks like this angle's twice as much as that angle in the picture? No. But don't worry about that. They don't have to draw it to scale. Okay? Everyone write that down.